Hi all, welcome to my YouTube channel Know About Embedded System. In this video, I'm going to give one hands-on session on bitmasking using Keil software. So whatever we have discussed theory topic in the previous video, the same thing I'll be giving a demonstration or hands-on session using a Keil software. So let us start the video. Before starting the video, so kindly share this, kindly like this, share this, and subscribe my channel to know more about embedded system. So without further delay, let us start this today's video, bitmasking with hands-on. So yes, in the last video we have discussed the same thing in the last video. The first operation, what you are saying, this operation is used to set the bits, and the second operation is used to clear the bits, and third one is used to toggle the bits. Here x stands for the left operator, x stands for the mask value, how many bits need to be masked, and then the y is the position, and z is your destination operator. So keeping this in mind, let us write one small code. Here you can see I have already written the code and I kept it ready for demonstration. Program, I have created one variable here, integer character I, and then I have created one variable x is equal to 0 I have created, and I'm going to use port 0 here. I'm going to use a port 0. So what is this port 0? If you want to know, you can watch my video microcontroller and microprocessor. There in detail I have explained what is port 0, port 1 and all. So port 0, the line number 7, what you're saying, this is a port 0. Port 0 is nothing but peripheral, and x is the variable. I'm just putting the value of x here to the port 0, and then I'm just creating one for loop here for I is equal to 0, I less than 8, and I plus plus. So totally 8 times I'm going to execute this loop, and I'm going to perform the operation set position. So here the logic, whatever I have written, try to understand what I'm doing here. I'm going to set the ith position. I need to set the ith position. I means initially 0. Here you can see for in the first time I will be 0. The 0th bit will be set, and it will be performed OR operation with x. Initially x will be 0. 0th position will set, and I will get increment. I will become 1. Second time this will become 1, and third time it will become 1. Fourth time it will become 1, and it goes on like that. So totally 8 times loop will be executed. After 8th time, your data looks like this: 1 1 1 1 1 1. Because I am incrementing 0 to 8. Sorry, 0 to 7 I'm incrementing, and the output, whatever it is getting, that output I'm going to feed it to the port 0. Let us go and compile and execute this code. Here in the bottom you can see you will get if there is any error, or if there are any errors, it will show in the bottom here. This is the build output window. As of now there is no error. I will just go here. This is called debug window. Go here, and in the debug window, I told you port 0 is my output port. In the port 0 I'm going to see the output. So go to port here, peripherals, and go to port IO ports and select port 0. Okay, now let us check, and here if you want to check output, here also it is fine. Here you can see there is a x variable and there is a I variable, so both outputs you can check here as well. Here as well you can check. Now I'll go. This is called step in. Step in means step by step execution it will start. Let us go one by one. So what is happening? This arrow indicates the execution line. Currently I'm going to execute line number 7. Here you can see the port 0 is getting 0 here, and x is also getting 0 here. Okay, now let us come here. Now I'm going to execute. I is equal to, you can see I is 0 and x is still 0. Now you can see x got incremented. X became 1. Now the same thing will be reflected in port 0. So port 0, it is a 8-bit register, 8-bit port it is, and in this port you can see the output. Okay, now you can see the I became 1. Now you can see here, now it got 3 in the sense 1 XOR with 1. So now 2 bits got set. Now you can see the second bit is also set, and similar to that I'll go for third iteration. Now the X became 7. Now third bit it is setting in port 0, and you can see here now X becomes F, nothing but 4-bit. Output port 0 will get with 4 number of ones, and if I go like that, 5 and then 6 and then 7, and then it will help, right? So this is called set principle, set operation. Using OR operation or bitwise OR operation, we're going to set the bits with the help of bit masking procedure. The second use case says like this. The first use case we have done successfully. We have set the bit. Now I'm going to clear the bits. I want to clear the bits. If you want to clear the bits, we have to follow small procedure here. Z is equal to and is equal to negation of X, left shift of Y. It is used. Go here. Now I'll do the small changes in the code. This is my second. I'm going to reset. I'm going to reset the ith position. So I made X is equal to FF. The X will be loaded to 0, and here X and with negation of I. This slight changes I will do, because if you compare the same thing whatever I have written in the slide. So slide Z and with negation of X, left shift of Y. Same procedure I have to follow. So now Z is nothing but X here, and is equal to negation of X, left shift of Y. The same logic I have taken from the PPT, and remaining rest of the code is same. Now what will happen, what is the expected output here is, initially in the first step all the bits will be in 1 1 1 1. This is my first step. This is my first step, or you can say initial step. So what will happen in case of when you go on executing the code, it is going to clear the bits like this. It is going to clear 2 bits, and then it goes on like that. 3 bits, then it goes on like that. So this is just a very simple code. So this process is called as clearing the bits. I'm going to clear the bits. At final stage you will get all zeros. This is your last stage. So this is the expected output in port 0. Right, now let us check the output, whether will it work or not. Save the code, compile, and go to debug window. So I have kept everything open now. So if you want, you can just close it and open IO ports, port 0. Now, so what is the value of X here? X, you can see now it is X is getting as FF. FF is nothing but all bits high. Now you can see the port 0 is getting as high. Now observe here, the last bit is getting, last pin is getting, yeah, here you can see the last bit blank is there. The blank in the sense it is 0. Okay, now next you see the second bit will go, the third bit will go, fourth bit will go, fifth bit will go, sixth bit will go, and seventh bit also will go. Finally, once it is done, right? So this is called resetting the bits. The resetting the bit is done by bitwise AND operator and by creating the mask value. The last one, toggle. So toggle, you can see here that for toggle operation we have to follow like this. Z is equal to cap. Cap is nothing but XOR operation, negation of X left shift of. Okay, now let us see whether will it work or not. So the same thing we will follow here. Come back to the code. In the code, let us keep FF only, no problem. And then here, I'm going to just toggle here. Toggle ith position. Okay. So I'll just, this time I'll keep it as 0. Position I'm keeping 0 in order to understand very clearly. So now what is the expectation here? So what code I have done the changes here. X is equal to X XOR with 1 left shift of 0. So meaning is pi. So toggle in the sense 1 and 0 continuously, it should change ones and zeros. Now we will see. You can see there it is getting toggled. Sorry, it's not getting toggled. I made a small mistake here. So you can see. So after 8 times it will stop. Okay, I'll just rerun it. Let us. Okay, it's not actually. It is not this here. Its negation is not required. So directly you can use. So just I'll go once again. Whether will it, okay, now this time what I will do, I'll just keep one while loop here instead of this. I'm going to create one while loop. Now let us check what will happen. The continuously port 0.0 should get toggled. Now you can observe there. Yes, continuously port 0 is getting toggled. Yeah, so this process is called as toggle. So like this, I hope this session is clear to all. Maybe in the next video I will take one more use case and I'll come back. So with that we will also understand further more about the bit masking. So with this I just want to end my video here. Like this video, share this video and subscribe my YouTube channel Know About Embedded System. Okay, so we'll meet you in the next video. Until then, just keep on watching our channel Know About Embedded System. Thank you.